Hey, this video is for JC Mole. She's one of my good friends. She's a business baddie and she knows nothing about proteins. So this is for you, JC. Today I am doing MC1R, which stands for melanocortin 1 receptor. MC1R is a protein that's located in your melanocytes on humans and animals, and it's responsible for producing dark pigmentation in your skin and fur color for the animals. So it produces this pigment, and normally it produces this pigment that's dark, and it's called eumelanin. And basically what happens is the MC1R protein receives a signal, and the signal is like, okay, we're gonna produce dark pigment melanin. So typically this is the protein. I have a loofah and then I have rubber bands, and each of these rubber bands represents an amino acid. So typically this protein would be in like a spiral coil shape due to its alpha helices. That just creates a spiral coil shape, and it works pretty much on its own. There's not too much interaction with other proteins, but today I'm going to be talking about what happens when the protein MC1R is mutated. And so the mutation is called R67C. So each of these rubber bands represents an amino acid, and I'm using a hair tie to show this. But when R67C comes in, it's the 67th amino acid in the chain that is affected. And when that happens, the signals that MC1R receives are weakened, if not able to go through at all. And so here's our little mutation. So remember, it's like in a coil structure. And so instead of producing eumelanin, it's going to produce pheomelanin. And pheomelanin is the reddish yellowish pigment in our skin. And so that's associated with fair skin and freckles and your gingers, like redheads. And so there's not as much protection against UV radiation. And what happens with this amino acid is arginine is replaced by cysteine. And arginine is a positive charge and cysteine is a neutral charge. So it changes how the protein folds and interacts. So it's a little bit different, and that's why the signals aren't able to go through, and it ends up producing pheomelanin because it's not getting the signals of, oh, I need to produce eumelanin for the dark pigment. So that's pretty much how the MC1R protein works. A couple limitations to this model that I've made is it's not to scale. Obviously, proteins are a lot smaller. They're in your melanocytes, which are in your skin. And this protein would typically fold like this, and so it goes in and out of your cell membrane. So this mutation is on the intracellular side of your membrane. And so it's not model to scale. This is much bigger than what it would actually look like, but this is just so you have a visual representation of what this protein would look like. And I will also say that this protein is fixed. Proteins are always constantly moving. They're always constantly changing in our bodies. Something's always happening. And so it's not always going to stay like this. Something's going to happen. It's going to be folded in different ways. Structure might be changed. So it's not always going to be exactly like this. And the model can't show chemical reactions. You can't see hydrogen bonds. You can't see chemically what's going on in order to produce these signals and end up producing eumelanin for the dark pigment to protect against UV radiation. And one more thing is, because this protein sits in the cell membrane, there are a lot of other molecules around it. So this doesn't show the environment that's around MC1R. It kind of just shows the protein itself. But other than that, that's the protein. So thank you for watching. I hope you enjoyed. And I hope you know a little bit more about MC1R.